Math 1314, section IC1, spring 2022, Tyler Junior College, section 7.2, polynomial functions, video 3, end behavior, factored polynomials. In the previous video, we determined, the following about the end behavior of polynomial functions. Suppose f of x equals a times x to the n plus a bunch of other stuff, where n equals the degree of f of x. Okay, let's pause and make sure we understand what we're being given here. When I say f of x equals this, and specifically I'm focusing on the leading term, what I'm saying is we have something at the beginning of the function where the first term represents the degree. And remember that degree means highest power. So in other words, we're only concerned with the term of the function that has the highest power on the x. So keep that in mind. Now, if we know what the leading term is, the highest powered term, and we know the leading coefficient, meaning the number in front of it, so the leading coefficient on this one is the a, and we know the degree, we'll put the degree in a different color. We'll put it in a light blue. If I can draw. If we know the degree, n, and we know the leading coefficient, for now we're just calling it a. I'm not bothering subscripting it with an n like we did in the very first video, because we're only looking at that one term. But if we know that information, then we can say two things. The first thing we can say depends on whether a is positive or negative. If a is greater than 0, then the right end rises. And if a is less than 0, then the right end falls. In other words, if the first term is your highest powered term, it doesn't even have to be the first term, but the sign in front of the highest powered term tells you the direction the right end points. I just drew a blank. If the leading coefficient a is positive, then the right end points in the positive direction. This is my right. It's my left. Here's my right. Then the right end points up positively. However, if the leading coefficient is negative, then the right end points down negatively. So the sign of the leading coefficient tells you what the right end does. And the degree tells you the relationship between the end behavior of the left end and the right end. If the n is even, then the left and right ends have equal behavior, meaning that they both point up or they both point down. But if the n is odd, then the left and right ends have opposite behavior, meaning that if the highest power is odd, then one end points up and one points down. Which points up and points down depends upon the answer to which end does the right fall. Which end is the right end point, which direction the right end points. I'm going to get the words right here in just a second. Now, I didn't do this in the last video, but you could draw a table that summarizes all of this information. And it would look a little something like this. Let's see, we need a vertical line here and a horizontal line here. And the rows and columns could be separated based on what the degree and leading coefficient do. For example, we could say a is greater than 0 here, and a is less than 0 here. And on the left, we could say n is even, and we could say n is odd. Now, with these combinations, we could actually figure out the end behavior. If a is greater than 0, if the first number is greater than 0, that means the right end rises. However, if a is less than 0, that means the right end falls. So we could draw a falling arrow on the right. Now, if n is even, then the ends are equal. So in the top row, the ends point the same direction. But if n is odd, then the ends are opposite, which means if one points up, the other points down. So you could summarize all four combinations of end behavior in this table, and I guess you could commit it to memory. But if you don't have a reason for putting the arrows where, then it's just hopefully that I remember it looks like this. Just remember, A, the leading coefficient sign, tells you which end the right point. So positive is up, negative is down. Going to highlight in yellow real quick. When A is positive, that means the right end goes up. And when A is negative, that means the right end goes down. And then the degree, the n, tells you equal or opposite depending upon if n is even or odd. So in the top row, in each box, the arrows are pointing the same way. And in the bottom row, each box, the arrows are pointing opposite directions. Well, that's cute and all, except there's a problem. However, some polynomial functions are already factored, and hence their leading term is not clear. For example, look at this function, f of x equals -1/2 x squared plus, -1/2 x squared times x plus 3 times 2x minus 1 to the 4th power. Now, there will be some situations where being factored is good. This is not one of them. Why? In such a case, there's something missing here. The leading term is not clear. Never mind, everything is here. I thought there was something down here that was hidden, but I don't see anything, so never mind. All right, in such a case, it's not necessary to multiply all the factors out to locate the leading term, because remember, our strategy for finding the end behavior is to know what the leading term is, this guy over here. If we know what that looks like, then we can analyze it into oblivion and figure out what all the ends do. But in a situation like this, we don't know what it is. So in such a case, you might think we have to multiply it all out, distribute, FOIL, et cetera, get rid of all the parentheses. But that will give us every single term in the function, and we don't need every single term. We only need the leading term. So it's not necessary to multiply all factors to locate the leading term. All you need to do is find the product of the leading terms of each factor. I want to focus on that ending phrase, the product of the leading terms of each factor. In fact, I want to sub-focus, if you will, on this phrase, leading terms of each factor. Well, by definition, a factor is part of a multiplication problem. So this function has 3 factors: 1/2 x squared, x plus 3, and 2x minus 1 to the 4th power. Each of those factors has a leading term, meaning a part with the highest power. In the first one, the only term in the first factor is -1/2 x squared. So that's going to be part of what we multiply together. In the second one, the leading term is x. In fact, I meant to highlight the -1/2 x squared as the leading term of the first factor, and I'm going to put the blue box back around it. So the leading term in the first factor is the only term, -1/2 x squared. The leading term in the second factor, the term with the highest power, is just the x. And the leading term in the third power, inside the parentheses, the term with the highest power is 2x. Now, here's where you got to be careful. If you are grabbing a leading term from a factor, and that factor has a power on it, like this 4, then it's necessary to use that as well. And the reason is that 4 means I would write this parentheses 4 times. 2x minus 1, 2x minus 1, 2x minus 1, 2x minus 1. So if I were to locate the leading term in all of those factors, it would be 2x, 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 and 2x. It would be 4 of them. Well, if there's 4 of them, I can just raise 2x to the 4th power. So what we're going to do to find the leading term for a polynomial function that's already factored is find the product, aka answer to the multiplication problem, of the leading terms of each factor. And it goes something like this. This function is going to start out with whatever the answer to 1/2 x squared times x times 2x to the 4th power is. and then there would be more stuff after it. But we're not concerned with the stuff after it. We're just concerned with the leading term, and that leading term is going to be whatever we get when we multiply all this together. Now, this isn't nearly as hard to multiply as it may seem, but it might help if we just kind of go to the side over here in a little thought cloud and figure out what this is going to equal. The only part of this that really takes some figuring out is the 2x to the 4th power. So I'm going to erase the red cloud, and I'll put the cloud around it when I know how big it needs to be. But we have 1/2 x squared times x. And for 2x to the 4th power, we could write 2x 4 times in a row, but that's the same as saying 2 to the 4th power and x to the 4th power. And then we could clean this up. Well, if you count up all the x's, there are 2 of them here, 1 of them here, and 4 of them there. That's a total of 7 x's. You could also just add the powers. So we're going to have an x to the 7th power. Now, as far as the numerical factors, the numbers, we have 1/2, and we have 2 to the 4th power. Well, that means 1/2 times 2 times 2 times 2 times 2. Well, 2 times 2 times 2 times 2 is 16, and then half of 16 is 8. So if we clean up the numerical parts, we get 8. And that means, oops, I left something off. Shame on me. The very first blue box has a negative 1/2 x squared, which means the very first factor should not have been 1/2 x squared, but rather negative 1/2 x squared. Which means over in this red thought cloud, that 1/2 should have been negative, which means the 8 at the end is going to be negative. And now I know how big to make this cloud. All right. So again, to find the leading term in a factored polynomial function, you only need to multiply the leading terms of all factors, including any powers that might be on that factor. In this case, this 4 was included right there. So this function will start out with negative 8x to the 7th, followed by some stuff that I didn't calculate, nor did I intend to, because I don't need it. For in behavior, I only need to know the leading term. And now we can analyze the leading term. In this leading term, the a, the number in front of the highest power, is negative 8, and the degree is 7. So what does this tell us about the in behavior? Because the leading coefficient is negative, that means that the right falls, the right end falls. We'll just say right falls for short. But what does the left do? Well, the degree is odd, which means the ends do opposite things. So if the right falls, then the left rises. And therefore, we have the end behavior. The end behavior is the left rises and the right falls. So we could verify this in Desmos. We're going to verify it real quick. We have to do some zooming in and zooming out, but it should give us left rises and right falls. Come on, bring me to Desmos. There we go. All right, we'll type in that function. F of x equals negative 1/2 x squared, excuse me, x squared, you don't belong there. Didn't get out of the denominator. X squared times, get out of the exponent, times, I believe it was 2x minus 1. I'm going to go back and look real quick. I'll have to reshare it. Hold on. I already forgot what the function was. X plus 3 and then 2x minus 1 to the 4th power. X plus 3 and 2x minus 1 to the 4th power. X plus 3 and then 2x minus 1 to the 4th power. And it looks like a really weird graph. Let's do this to make it a little bit thicker. And let's zoom out and see if we can see what we see. Okay, well, we zoomed out quite a bit, so let's do this instead. Instead of zooming out and squishing the x's as well, we just need to squish the y's. So I'm going to go into here and tell it I want the y-axis to go all the way down from negative 100 to positive 100. Looks like we need to go more than that. Let's go to negative 500 to positive 500. And look at that, we still can't even see the bottom of the graph. We have to go really low. Where's the bottom of that? There it is, right down there. We need to go down to the 2000s. All right, let's do this again. Y-axis, I want you to go beyond negative 2000. We'll say negative 2500. And let's go all the way up to 2500. And now we kind of see the graph. Starts high, dips, does a little wavy thing in the middle that we can't see because we're zoomed so far out, and then it drops down. But it is confirming what we said, that the left end is rising and the right end is falling. Now, some of you are thinking, can I just go into Desmos, draw the graph, and answer what the end behavior is? And the answer is yes, but there are some questions later where that will not be an option. All right, we're going to take a look at one more and wrap up this video. Find the end behavior of the function's graph. G of x equals 3x times the quantity x minus 5 squared times the quantity x plus 4 to the fourth. Remember, all we need to determine the end behavior is the leading term. And to find the leading term, we just find the product of the leading terms of each factor. Factor is part of a multiplication problem, in case you weren't clear. This function has three factors: 3x, x minus 5, which is squared, and x plus 4, which is raised to the fourth power. The first factor of 3x only has one term, so its leading term is 3x. The second factor has two terms, x and minus 5. Its leading term is x, but that factor has a power of 2, so we'll bring it along. And the third factor, x plus 4 to the fourth power, has two terms on the inside. The leading term is also x, but that factor has a power of 4. So this means that our function will start with the answer to 3x times x squared times x to the fourth. And I would be remiss if I didn't put plus dot, 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 because there is more stuff out there we're just not representing. If I don't put that, then I'm saying this is the only term in the function, which is not. So plus more stuff that I don't know, nor do I need to know. I just have to multiply all these things out. So our function will begin with, let's count up all the x's, shall we? This x, the last one is 4 x's, the middle one is 2 x's, and the implied exponent on that one is 1. So we have 1 plus 2 plus 4 more x's for a total of 7. So we're going to have x to the 7th again. You know, just for kicks and giggles. If you've already found this one out, that's great. I'm going to modify this problem briefly. I'm going to put a square on the 3x in the front. Okay, which means we're going to end up with x to the 8th. And the product of the coefficients, the numbers in front of the x's, well, there's a 3, there's an implied 1, and there's an implied 1. 3 times 1 times 1, of course, is 3. This modified function that starts with 3x squared is going to start with 3x to the 8th as its first term. So what does that tell us? Well, we know that the leading coefficient is 3, and we know that the degree is 8. Because the leading coefficient is 3, and more specifically, the leading coefficient is greater than 0, this means that the right rises. And because 8 is even, that means we have equal ends. So if the right rises and the ends are equal, that means the left rises also. We could say the left rises and right rises. You could also say both ends rise. So it's really not that difficult to find the end behavior of a factored polynomial function. We just have to dig out the leading term by finding the product, the multiplication problem of the leading terms of the individual factors, along with any powers that might be on those factors.